Hello everyone, what's up? Today I'm going to show you how you can integrate cosine squared. So now that may seem like a bit of a hard integral. You might have thought about integrating 1 minus sine squared. That's one approach, but then you have to deal with the integral of sine squared. And it's actually, you could do it, you know. The way in which you solve the integral of sine squared is very similar to the way in which you solve the integral of cosine squared. But today I'm going to show you, I think if I show you one way to solve this integral, you're gonna know how to solve the integral of sine squared. So that's something nice, you know. And yeah, I'm just gonna show you how to solve this, okay? And then you can apply that reasoning to the integral of sine squared, which are pretty much the same to some extent. So to solve this, I will use a very important formula. Hopefully you know about it, and if you don't, then you're gonna learn about it here. So there's something called the half angle or double angle formulas, and it's a whole family of very very interconnected formulas, and I'm just going to use one of them, which is this one. Actually, I'm going to give you the two of them just so you have some idea of how you can do the integral of sine squared too. So sine squared, there's one way in which you can reduce the degree of sine to something that has a degree of 1, to an expression of degree 1, and it's like this. So sine squared will be equal to cosine of 2 theta divided by 2, this is 1, and the other one, which is the one I'll use for this video, cosine squared theta is going to be 1 plus cosine of 2 theta divided by 2, okay? So these two equations are very important, and we're going to use this one for that integral, but really if you have the integral of sine squared, you can just use this one. But today I'm going to focus on cosine squared, okay? So now using this equation, we're going to do the following. We're just simply going to rewrite this as the integral of 1 plus cosine of 2 theta divided by 2 d theta, okay? Now, we do this because it is way easier to deal with first degree functions instead of squares, okay? Like, you know what the integral of cosine is, but it's kind of hard. I mean, you can't really just know off the top of your head the integral of cosine squared. You need to do some more steps like what we're about to do. So you do know the integral of cosine, which is what we have here. And you don't know the integral of cosine squared, okay? So the reasoning behind why we rewrote cosine squared like this is because we want to have a first degree function, okay? Or we want to be able to have lower degree functions instead of higher order functions, okay? Which is what we started with. So that's the reasoning behind, why we use this equation, and why that's the most important thing you should try to do in almost any integral. In any integral, you want to be able to get to a form that is easy to integrate. You want to be able to have a low degree function, okay, which are typically easy to integrate. So yeah, now let's continue. So now we just need to integrate this. And now to integrate that is really easy. We just simply need to integrate each term. So we're going to have a half plus cosine 2 theta over 2. So the integral of a half, we know is going to be theta divided by 2. And now we're going to have over here, we're just going to do it like this, plus the integral of cosine of 2 theta divided by 2 d theta. And we know this will be equal to theta over 2. Now, what is the integral of cosine 2 theta divided by 2? You can actually just figure that out off the top of your head. So you can do it like this. So you're going to have the integral of the derivative of sine is going to be cosine, okay? So that's a starting point. Now, what if you have the derivative of sine 2 theta? Well, you're going to get cosine 2 theta, which is exactly what we have here. And now, how do we take care of this factor of a half? Well, if you have the integral of sine, so I'm just going to write it here. You have the derivative, of 2 theta, sine 2 theta. This, will be equal to 2 times cosine 2 theta. Now we want to have, instead of having 2 times cosine 2 theta, we want to have cosine 2 theta over 2. What do you do? Well, the only thing you need to do is to just simply divide by 4 on both sides, okay? And then you get this, meaning the function that you are looking for, it's simply going to be equal to sine of 2 theta divided by 4, okay? And then, of course, you can't forget c. So yeah, now notice if you differentiate this, we can actually prove this real quick, just to make sure we're right. So if we differentiate this function, well, what do we get? We're going to get a half, then we're going to get plus. Now, what we just did here, the derivative of sine 2 theta divided by 4, we know that's just going to be 2 times cosine 2 theta divided by 4, which is equal to a half plus cosine 2 theta a half Now notice this formula up here. Well, we know this will just be equal to cosine squared theta, okay? Which is what we started with. So yeah, this is also the proof that this solution is correct, okay? I'm sure there may be some more solutions. Actually, I'm not sure, but you know how flexible trigonometric functions are. You can rewrite them in terms of so many other things. So yeah, I'm pretty sure there may be other ways not to rewrite this, but to get to a different answer, okay? Maybe with this constant you can do something, but yeah, that's outside the scope of this video, so yeah. Yeah, this is the solution. Hopefully you enjoyed this. This is a relatively short video because this integral is actually really easy. As long as you know this equation, or maybe also this one, you can derive this equation from this one actually, just as a side note. Or the other way around, you can derive this one from this one. Because pretty much they are the same equation. It's really weird, you know how math is. Yeah, they're almost the same equation. Yeah, they're pretty much the same equation. Yeah, anyways, that's not the point. What was I saying? Yeah, so this integral is really easy as long as you know these equations over here, okay? So that's the entire video. Hopefully you enjoyed it, and see you in the following one. Bye.